Okay. Chalo. Next question. Let's see. Let's talk about the answers. Or maybe let's try to solve this particular question orally. Yeah.
Yeah, so
Either that or see, I have taught you, right? Ki whenever there's a question of at least one, it is the fastest method to solve total minus no. Right? So
yeah,
total number of selection is what? You have 11 people, 11C5 minus
yeah,
the number of cases when you have no women, which is
yeah,
65, right? You'll just select 5 men, no women. So 11C5 minus 65 or what you're saying also makes sense, but try to do it in the fashion total minus no will always be faster.
yeah,
Second question, a particular woman is always present. Whosoever that woman is, select it, put it in the team. Now you're left with what? 6 men and 4 women. You have to select 4 more members. It could be anything, no constraint. So simple answer is 10C4.
it's-
One particular woman, which means you have already selected her, right? There is no selection, no permutation. That is selected out of 10 members. Select any 4, 10C4. Third question, a particular man is always absent. Whosoever that man is, remove him from the list. You're left with 5 men, 5 women, total 10. You have to select 5-member team. 10C5 is the answer. Fourth question, 2 particular women insist on going together. What do you do? What does this particular question mean? Insist on going together का क्या मतलब है? Sai, please tell me.
They
What do you
want
mean
both
together?
they want to do both want.
Yes, Sai.
Like, sir, like either two will be, both of them will be there, or neither of them will be.
Very good. Awesome. Insist on going together means if they are going, they must go together. So either they would go and both of them would go, or neither of it would go. It can't happen that that one of the women is going and the second is not going. Which means case number 1, 2 particular women are in the team. So if 2 women are already chosen, you're left with 6 men and 3 women. So total 9 member. You have to select 3-member team now because 2 you have already chosen, 9C3. Or case number 2, 2 women is not going. You have 9 member now, 6 men, 3 women, and you have to select 5 members from it, 9C5. So the answer to this question should be 9C3 plus 9C5. Last question, 2 particular women insist of not going together. Either one of them go or none of them go. Fair, good. So if I have 2 women, if I have 2 men, M1, M2, either M1 is going or M2 is going or none of them is going. The only thing they're saying is both of them should not go together. So either you make cases solve it or you find that the total number of cases is 11C5. You just subtract the case when these 2 are going together. So 2 men going together is, you choose 2 men, left out is 4 men, 5 women, 9 member. You choose a team of 9C3 because 2 you have already chosen. So 11C5 minus 9C3 becomes your answer to question number 5. Clear? A very good question, but something which we just solved orally. 8. Chalo. Let's move on to the next question. Now this is the trickier one, geometry based. Cool. Let's jump onto this concept first. And I would ask everyone again after 15 minutes, what is your confidence level in PNC based geometry questions? So again, I'm sure we don't need to. Okay, let me show the question first. Maximum number of intersections of 12 straight lines. I would solve this question first. I'll talk about the concept in PNC. Whenever there is any question on the number of intersection points, maximum number of intersection points, always whatever figure that is, whether it's a line or a circle or a square or a quadrilateral or a pentagon, whatever it is, this is the same method that would be applicable. Because the question says maximum number of intersection, the method always is, you first of all try to draw the diagram. Always try to draw the diagram and then try to visualize that, okay, for the minimum number of intersection, how many straight lines do you need? Right? So what you do is, step one, always try to think in this direction. How many minimum lines, because you have to find the maximum number of intersection, right? So what you will do is you will try to maximize the number of intersection with the minimum number of lines. Minimum lines for an intersection. Step number one, again, you just have to think how many minimum lines are needed for the intersection, and I want an answer from everyone. How many lines are needed for an intersection? And after you do this, you have to find the maximum number of points. Say these number of lines come out to be equals to P, right? Then you have to maximize the number of points of intersection using these P lines, right? And then third is simply PNC, right? That you would try to, for example, there are 12 straight lines, right? So you will simply select, okay, 12 CP into whatever is that number of intersections. Third part is simple PNC, but is the first and the second part clear? I want an answer. How many number of lines? Okay, I think Rupal, Akanksha, 2 girls have already answered. Others? Fair. So first point is identify the minimum number of lines for an intersection. For example, how many lines do you need for an intersection? Minimum you need 2 lines, right? 2. Now, if you have 2 lines, how many maximum number of intersection points can you have with 2 lines? No matter how you draw them, you can only have one intersection, right? That's it. This is what it means. The maximum number of intersection points using these 2 lines. So again, first of all, we know I need minimum 2 lines. If I have any 2 lines, I can have a maximum of 1 intersection point from them, right? So now the way you approach these questions of geometry is you select. In how many ways can you select 2 lines? If you have 12 straight lines, you need minimum 2 lines. In how many ways can you select 2 lines? 12C2. Now that you have selected any 2 lines, what is the maximum number of intersection point you can have with the 2 lines? 1. So this becomes your direct answer. 12C2 into 1, whatever this is, 12 into 11 by 2, this is nothing but 66. I'll repeat myself. Always remember this method, and most of you should be able to think it like, why am I trying to talk about this method? Whenever we have to find out maximum number of intersection points in any curve, mentally think how many minimum figures do you need for an intersection. For example, here you definitely need 2 lines minimum to draw an intersection. Now, if you have 2 lines, what is that maximum number of points of intersection that you can have, right? So in how many ways can you select 2 lines? It is 12C2, and using 2 lines, how many are the number of maximum points that you can have for intersection? 1. Always try. See, I can have 2 parallel lines as well, right? Number of intersection point is 0. But because we have to maximize it, we will talk about the maximum intersection point, which is 1. Clear everyone with the method? Yes, no?
Yes, sir.
Awesome. Everyone, engineers, non-engineers, boys, girls, working freshers. Great. If this is clear, this is an advanced question. Many students are not able to solve it, but I want all the students to be able to solve this question now. The answer is 132, and I'm super proud of all of you. How many minimum circles do I need for an intersection? I need 2 circles. If I have 2 circles, how many maximum number of intersection points can I have? No matter where I keep the circles, I can always have 2 intersection points. Simple. In how many ways will I select 2 circles? 12C2. If I have 2 circles, the number of intersection points will be 2. This becomes your answer. One liner, 10-second questions, but this is a difficult question. Not everyone is able to understand it. Awesome. Next question is even interesting than this. Let's see how many of you can really think about it. And I'm saying this is like an LOD 4 Olympiad level of question. Think very carefully about this. Method is same, but please think very carefully. The correct answer is 12C2 into 6. See, you should be able to, as long as you're able to visualize it. Method is same. If you can visualize it within 30 seconds, well and good. If you're not able to visualize it, just leave that. That's the only option. No other method is there. Method is same. Okay? And ideally, you will be able to see in majority of it. See how many minimum triangles you need. The only mistake students make here is they draw a triangle like this, or they will draw a triangle like this, like this only, right? But this has what? Only two intersection. But because I said you have to maximize your intersection, hence the triangles have to be inverted, right? Only then you will have how many intersections? 3, 4, 5, and 6. Now simple, you simply need two triangles. Once you have two triangles, the maximum number of intersection points is. But this, not many students are able to visualize this thing. The most common mistake here is 12C2 into 2, and this will be in one of the answer. Let's solve one tough question now. Sorry. Yeah, this one. You have 12 circles, you have 15 straight lines. Now, how do you maximize the number of intersections? There's a trick here. See, until now, we were just having similar sort of figures, right? Now the figure changes. So whatever we are learning holds true when we have a singular type of figure. It's all circles or all straight lines or all triangles. Here you have multiple kinds of figures, right? You have different kinds of figures. So how do you do that? How do you translate this question to what we just learned? And why were we doing what we just did is because, okay, two circles can intersect. So I'll choose two circles and make them intersect. Two lines can intersect. I'll choose two lines and then intersect. Here you have circles as well as straight lines. So very good, Mang. So this was a very conceptual thing. Why can't we say, okay, I'll choose any two figures and then whatever two figures I choose will intersect at one or two times? We can't do this because if I choose two straight lines, they will only intersect once. If I choose two circles, they will intersect twice. If I choose one circle and one line, they will intersect twice. So because the total number of intersections are not even, we can't really do that. And even if I choose 27C3, 7C4, what Raman tried to do, we don't know what these two or three figures are, right? Because we don't know, we can't really do that because we won't know how many times would they intersect. Clear? Why can't we do this? So every student who tried to do 27C something, we can't do that here. Right? Because you're not sure.
No, sir, I didn't try that way.
Okay, fair. Hence, what do you do right now is, see, you have 12 circles, right? So you simply know, if I select any two circles, how many times would they intersect? They would intersect twice. This is a known thing to us. Similarly, you have 15 straight lines. So number of intersection points within circle plus number of intersection points within lines, 15C2 into 1. Plus, either it could be two circles, intersect them, or it could be two straight lines, intersect them, or it could be one circle as well as one straight lines. Which means, in how many ways can you select one circle? 12C1 into 15C1 into 2. You solve all of it, I think you'll get answer as 597 or something. Yeah, you can consider it as in like, what do you want me to do? These will be two circles and one straight line,
And
right?
one straight line. Here we have maximum number of intersections as 4, right?
Correct.
So where is this case covered in our answer?
Where is this case covered in our answer? Okay.
I mean, we need to consider this separately. I mean to say that
No,
we
no,
need to
no.
consider this
You
separately.
don't have to consider this separately. See, the number of, see, this has what? This has total 6 number of intersection format, right?
Yeah.
So if you have to apply the same formula here, I'm just trying to minimize it so that you can understand. What would I have done? I have two circle. I'll choose two circles. Maximum number of intersection is 2. I have only one line. It doesn't matter. Now I have one circle and one line. So I'll choose any one circle in 2C1. Ways I have only one line, 1C1. They will intersect in two positions. I'll solve this. I'll get answer as 6. This is matching my answer, right? 6. So This case will be covered when you are saying 12C2, right? You have already considered this case, this and this.
Yeah,
Right? This is already covered here. Now, when you're saying 12C1 into 15C1, you're actually covering, see, this case, circle 1, circle 2. So circle 1 and this line 1 ka jo intersection hai, this is covered here. When we said 12C1 into 5C1 into 2, this case is already covered. Similarly, these are all the other permutation combinations of a line and a circle, right? So this second case, when this line intersects the circle 2, line 1 intersecting to circle 2 is also covered here. Hence, the remaining 2 points also get covered in this. So this includes all the combinations of within circles is covered here. Line and circle ka is covered here. Chinmay, does that help you understand? Where is it?
Yes. Yeah, got it.
Fair. With everyone else, we are clear with this question?
So basically what we can say, if we need maximum number of intersection, we need to consider is minimum number of figures to be intersected.
Absolutely, yes.
Okay.
Because that will help you visualize, and then you will say, okay, I'll choose those minimum number circles, make them intersect, and then keep on doing this within the figures. Let's move on to the next concept, circular permutation. It's an easy one. Okay. See, if I tell you in how many ways can you arrange 3 friends sitting in a row? Say friends are A, B, C. In how many ways can you arrange them in a row? What would be your answer?
3 factorial.
Everyone, 3 factorial? Simple 6 ways: ABC, ACB, BAC, BCA, CAB, CBA. 6 number of ways. Now everyone, if I ask you, in how many ways can you arrange 3 friends in a circle? This is a circle. Please try arranging these 3 friends. Every single student should be able to try it manually. I don't want you to apply mind, come up with a formula. Just try to make all the possible cases here. And tell me how many ways can you do it? Fair. Shrijan, can you please explain what these 3 cases would be? You said 3 cases. Please unmute and tell me what would be these 3 cases.
Sir, one will be A sitting on the top and B on the right side and C on the left side.
Okay.
And the next would be B sitting on the top, A on the left, and C on the right. And then
Okay.
third would be C sitting on the top,
Okay.
B on the left, and A on the
Okay.
right.
And B on the right.
Yeah,
So
no,
this is A, B, C.
Yeah.
Isn't case number 1 and case number 2 same?
So B on the left and A on the right.
B on the left.
Last one.
Last is B on the left and A on the right. Aren't these 3 cases same? ABC, ABC, ABC. Are they any different? See, this is a circle, right?
Yeah.
In circle, how do you determine which is top, which is bottom?
Yes, right.
It's a circle, right? Every place is same. It's symmetrical. This is also ABC. This is also ABC. So this is also ABC. So all the 3 cases you said, Srijan, are actually same. Right?
Yes.
The only case that would be different is you consider A, C, and B. Now this is a different case because let's consider a guy who's sitting here, A. On the right hand side of A, you have B, and on the left hand side, you have C. In the first case, on the right hand side, I had C, on the left hand side, I had B. So these 2 cases are different. Otherwise, all the cases are actually same. So the answer to this question is not 3, it is actually 2. You have only 2 cases when it's a circle. Right? So a general formula for this is, if you have n students or n people who wants to be arranged in a circle, the answer is n minus 1 factorial. Why? Because you take any one person, right? You take any one person wherever he's sitting, you consider that as the starting point. So you essentially fixate one person. Once you have fixed it, then the remaining n minus 1 people, they can be arranged in n minus 1 factorial ways. You just fix any single person, whosoever this is, right? So again, you won't say NC1, right? Because you have to essentially arrange everyone, right? So whosoever that guy is, let it be here, and then the remaining n minus 1 people can be arranged in n minus 1 factorial number of ways. So the answer to this question, or the formula for circular arrangement, is n minus 1 factorial. Just some theory. If there are 5 people, fix any particular person, and just arrange the remaining 4. And this matters because clockwise and anti-clockwise are different thing, right? So if I take clockwise and if I take anti-clockwise, similar to how I was showing, right, in case of ABC, these are two different things. But now let's consider the cases when the clockwise and anti-clockwise is also same. Clockwise direction or anti-clockwise direction, it is same. Then the total number of cases would actually become, you first of all try to arrange them in a circle. Now because clockwise and anti-clockwise is also same, you'll divide it by 2. But first of all, even before going there, just try to think from your daily examples, any object where, whether it's clockwise or anti-clockwise, it is essentially same. Just try to think it out. Mohit says garland. Yes. See, if it's a necklace, right? You take, because necklace is like a 3D sort of object, right? It is a 3D object. So whether you see from front or you see from back, doesn't matter, right? You can always reverse that necklace. You can always reverse that particular garland. So whether it's on the front or on the back doesn't matter. So whether something is clockwise or anti-clockwise, all you have to do is just to sort of reverse it, and you'll be able to put clockwise into anti-clockwise and vice versa. So yes, if it is an object, a 3D sort of object, which is circular, the answer becomes n minus 1 factorial by 2. Now, it could be a circular ring or it could be a garland. Clockwise and anti-clockwise doesn't matter, so you would always divide the answers by 2. Right? Same necklace concept. It is called as necklace concept. Let's solve this question now. Simple question, should not take you guys more than 10 seconds now. See, there's a straight line and then there's a circle, right? For every straight line, there would be some circular arrangement. Now, what you do is you select 7 friends to be set here. 1, 2, 3, 4, 5, 6, 7, right? Now, for every sequence of this, there would be 5 factorial number of arrangements for this circle. So simply what you do is 13C7, arrange them 7 factorial. Now, for every one of them, there would be 5 factorial number of arrangements for this. Hence, there has to be a multiplication and not plus. Clear? And always when you're confused, take a smaller example. Take 3 friends, 2 of them sit in a circle. Maybe take 4 friends and then try to do this. So this will become more clearer too. But Chinmay, clear? Why into and not plus?
Yeah, got it.
Awesome.
Sir, here can we select firstly circular ones also, like 13C6 multiplied with factorial 5 and then
Absolutely. Absolutely, you can do that. 13C6 is selecting 6 friends in circle, arrange them in 5 factorial ways. The left out 7 people will be arranged in 7 factorial. Yes, it's going to be same.
So isn't 13C6 and 13C7 equal?
Yeah, it is. Hence, the answer comes out to be same. Sure. Let's do one advanced question now. Enough of easy questions. Let's see who can crack this. This is advanced. You can assume this to be a chocolate problem. Let's see if there's even one student who is able to get the right answer. And try to calculate the answers manually, like whatever expression comes out, give me the final number. Anand, can you explain how 30?
Sir, am I audible?
Yeah.
Sir, let's say there are 6 per cube, there are 6 faces, and first paint any color on any face,
Fair. Let's say I paint a bottom one. Okay.
Now the opposite face can be painted in 5 ways, like with any other 5 colors, remaining colors.
Good. So you're saying I'll just paint this with whatever color. Does not matter.
No. Uh-huh.
So
Like
this
first
can be
paint any color of it on any face, and the opposite can be painted in 5 ways with any of the remaining 5 colors.
correct. Good.
Now the remaining 4 faces can be painted in with the remaining 4 colors in like 4 minus 1 factorial ways. Like let's say it has circular permutation.
Okay. Good.
So
Awesome.
5
Yeah.
into
Yes. 30. Absolutely correct. I think this is the method to solve this question. You fixate any side, you just paint it with like whatever color you want to paint it with. Once you do it, you have to paint the remaining 4 and the 5 faces, right? So what you do is the one that is opposite to this, you have 5 options for it. Paint it also. Now you have painted 2 faces, right? So this is nothing but a circle. You have 4 colors. In how many ways can you arrange these 4 colors in a circular format? 4 minus 1 factorial. So the answer becomes 30. Very good. Okay, cool. Let's the next question. See, whenever there is symmetrical, try to draw the diagram, try to place it, and that would simplify you. Which one is symmetrical, which one is not symmetrical. Okay. Man, can you explain how 8 factorial?
Basically thought of it as a circular arrangement only. So,
And why circular arrangement? You want 3 places, right? Say 1, 2, 3, 1, 2, 3, 1, 2, 3, right? Fair. Cool. Why circular arrangement?
I mean, be it a triangular shaped, but people are sitting in circular fashion only, no? So that's why I thought.
Okay. See, in circular, what happens is whether someone is here, 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 anywhere, right? I can always rotate and I can bring this particular person in this position by just rotating it, right? Hence, what we do in circular is we just fixate one person because whosoever I fix, anyone can be in that position. But here, can we do that? For example, I try to name these people, right? 1, 2, 3. Let's try to name the base. Now, if I rotate this in this fashion, where would this one be? This would be here. So 1, 2, 3. If I then rotate this here, this would be 1, 1, 2, 3. So is it possible, Mayank, that this guy who is sitting at 3 here, can he ever be at 1 or 2?
Got it.
Got it, right? So it is because this is not possible for this guy to be here at 1 or 2. So I can't simply say, here, I can fix at anyone and then I would arrange. I know for a fact that whosoever, see, I will have to fixate one guy, right? So let's say I'm trying to fixate one position. Let's say number 1. Now, in how many number of ways can I fixate one? Either here or here or here. All of these are same if I'm trying to fixate one position. So I have 3 ways to fix number 1, 3C1. But now that I have fixed one guy here, say one person is sitting here, then every position is different. These are the positions towards left. These are the positions towards right. So now that I've fixed one, this 2 and this 2 becomes different. This is immediately right. This is after 2 positions to the left. And even this is different, right? This is farther off. So all I need is either fix it any 1 or any 2 or any 3. Whosoever I fix it, then the remaining 8% can be arranged in 8 factorial number of ways. So the answer to this question is not 8 factorial, but 8 factorial into 3C1. Fair? So yeah, I think we have covered this. Then I'll just touch upon one particular concept and then I'll give to all of you. Fair? So this is something you can take it as a homework. Same question. It's just this time it is an isosceles triangle. In last question where there were 9 people, in this question there's an 8 people. Solve it at home. Give me the answer. Okay. And I'll at least like to touch upon the next concept of dearrangement. Can anyone tell me what is dearrangement? Any student, just unmute and answer. What do you mean by dearrangement? So dearrangement is nothing but, see, at least so far what we have been doing is we are trying to arrange things within themselves. Dearrangement is you have to arrange things in such a fashion that none of the object goes to its correct place. So for example, you have letters and envelopes. That's like the classic example. You have 5 letters, 5 envelopes. Letter 1 was supposed to go in envelope 1, letter 2 in envelope 2, letter 3 in envelope 3, letter 4 in envelope 4, and letter 5 in envelope 5. Now, in how many ways can you arrange these 5 letters? Answer is simple, 5 factorial, 120 number of ways. However, if it says that letter 1 was supposed to go in envelope 1, then in how many ways can you arrange these letters such that no letter goes in its correct position? No letter should go in its correct position, which means the letter 1 can go either in 2, 3, 4, or 5. It cannot go in 1. Whenever such type of constraint comes, that becomes a question of dearrangement. Right? Is the concept clear? What is dearrangement? Dearrangement is essentially arranging objects such that no object is at its right place. That's dearrangement. Right? So the same example that I tried to give you. So now, can I ask you this question? If there is one letter and if there is one envelope, in how many ways can you arrange one letter into one envelope so that this letter does not go in its correct place? Everyone? Simple? 0, because there's only one option for it. So there is no option. It has to be in envelope 1, which is the correct one. So the number of places are 0. If I say you, I have 2 letters and there are 2 envelopes, in how many ways can you arrange them such that it does not go in its correct place? Say letter 1, envelope 1, letter 2, and envelope 2. In how many ways can you arrange them such that this should not go in its correct place and this should not go in its correct place? Good. Only one, right? Because letter 1 can't go here, it has to go here. If it goes here, letter 2 has to go here. So the number of ways is 1. Similarly, if there are now 3 letters, L1, L2, L3, and envelope 1, envelope 2, envelope 3, how do you arrange them? Letter 1 can come in 2. If letter 1 is in 2, case number 1, letter 1 is in 2. If L1 is in E2, L2 can be in either E1 or L2 can be in E3. If L2 is in E1, the letter 3 will be in E3, which is not possible, right? Because letter 3 cannot go in envelope 3. In this case, letter number 3 will be in envelope 1. This is possible. Again, second case, letter 1 is not in envelope 2, but it is in envelope 3. Similarly, L2 can't go in E2. So L2 has to go in E1. If L2 goes in E1, L3 has to go in E2. So this is that second case. So in total, I can have 2 cases in which I dearrange 3 letters. Clear, everyone? Raman, it is not n factorial minus 1.
Okay.
Clear? Because n factorial minus 1 kab hota, Raman? When I'm saying every letter has to be in its correct position. That is one number of ways. But here what I'm saying is none of the letter has to be in its correct position. Hence, you can't subtract 1. Clear?
Okay.
Everyone is clear with this concept? How do we solve dearrangement questions? But now, if I tell you, you have 10 letters and 10 arrangements, how would you dearrange them? How would you solve it? Dearrange 10 letters such that none letter goes to its right envelope. First question, will you be able to solve it? Second, would you attempt it in CAT? Can you solve it in 3 minutes? Fair.
So formulated.
Hence, we have to come up with some formula on how do we dearrange n objects. And the formula to that is this. I have to rearrange n objects. The formula is n factorial into 1 minus 1 factorial. The way in which you can remember this is this. 1 upon 0 factorial minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial and so on and so forth till you get the object. This becomes the formula. So for example, if I have to rearrange two objects, right? 2 factorial into 1 minus 1 upon 1 factorial plus 1 by 2 factorial. I will only go to till 2, right? So this gets cancelled. This is nothing but 1. We just checked for 2, right? If I have to rearrangement 3, it has to be 3 factorial, which is 6. This will get cancelled. 1 upon 2 minus 1 by 3 factorial, which is 6. So 3 minus 1, 2 by 6, right? 2, 3 minus 1, 2 by 6 into 6. 6 gets cancelled. The answer comes out to be 2, which we just checked. So this becomes your formula for rearrangement. Whenever now, if I ask you, you have to rearrange 10 objects, this is how you would do it. Something for you to remember is, everyone should at least remember till 4. Okay, rearrangement of 3 letters is 2, rearrangement of 4 letters is 9. Itna yaad rakh lo, that is more than enough. Okay. Is everyone clear? How do we solve rearrangement question? This method, how do we apply the formula? Yes, no? Awesome, guys. Then with this question is the homework for every student. In total, there are 7 parts. Every one of you should go and attempt this question, and we'll discuss it next weekend. Okay? Fair. So just take a screenshot. Fair, guys. I think a long session. It took us what? 2.5 hours. But I hope session was helpful. Enjoyed it. Gaining confidence in PNC.
Yes, sir.